Now let's talk about the quotient rule. The quotient, f divided by g, of two differentiable functions, f and g, is itself differentiable at all values of x, for which g of x does not equal 0. Moreover, the derivative of f to g is given by the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the square of the denominator. So the derivative with respect to x of f of x to g of x, again, is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator divided by this g of x quantity squared. That's the quotient rule in action. Now, let's take that quotient rule and deal with example 4. Example 4 states y is equal to 5x minus 2 divided by x squared plus 1. So y prime is going to equal. Here I take my denominator, which is x squared plus 1, times the derivative of my numerator, which is 5, minus my numerator, which is 5x minus 2, times the derivative of my denominator, which is 2x, divided by, and then we'd have this wonderful x to the second plus 1 quantity squared. That's right there, the employment of the quotient rule. Once, if you want to see a proof of this, you can read the book. I can go through it later. I don't think I want to type that up right now. But right now you're just worrying about trying to employ the rule. Down the road we'll clean it up. But right now you're just trying to employ the rule. This next example wants us to find the equation of the tangent line to the graph of f through the point -1, 1. Alrighty. So, if that is the case, essentially what we want to do is use our equation of a line, y minus 1 is equal to a slope times x plus 1, but we need to find the slope. So we need to find f prime of x. And to find f prime of x, I'm going to have to employ the quotient rule. So I would take my denominator times the derivative of the numerator. Well, before I even start differentiating, would one agree that this 3 minus 1 divided by x in differentiation user-friendly form is the same thing as 3 minus x to the -1? So, going back to finding the derivative, f prime of x, I take my denominator times the derivative of my numerator. Well, the derivative of my numerator is just 0 plus, because -1 times a negative is 1, x to the -2. So that's the same thing as 1 divided by x squared. Minus, and then I take my numerator, 3 minus 1 divided by x, it might be easier to evaluate in that form, times the derivative of the denominator, which is 1. All of that divided by this x plus 5 to the second. And that little -1, 1 should just be to the side there. So now I need to evaluate this at x equals -1. So I'm finding f prime of -1. So I'll have 4, and then when I plug in a -1 to 1 divided by x squared, I'll just have a 1 minus, and then I'll have 3 plus 1, which is 4, times 1, divided by, divided by, and then I'll just have 4 squared, which is 16. Well, that's 0. So my slope is 0. So my equation, my tangent lines, y minus 1 is equal to 0 times x plus 1. There you go. All the news that's fit to print. Hope this helps.